Hey everyone, in this video what we're going to do is we're going to solve the following second order differential equation. So we have the second derivative of f of x with respect to x is equal to the first derivative of f of x with respect to x plus f of x. So what we're going to do is we're going to begin by subtracting the first derivative of f of x with respect to x and f of x from both sides of this equation so that we have the following, which is the characteristic equation r squared minus r minus 1 equals 0. This is a quadratic equation, which we can solve using the quadratic formula. So if we take a to be equal to 1, and b to be equal to minus 1, and c to be equal to minus 1, we get two roots, 1 plus the square root of 5 divided by 2, and 1 minus the square root of 5 divided by 2. So we have two distinct real roots to our characteristic equation. What does this tell us about the form of our solutions to our second order linear differential equation? Well, it tells us that we have one solution f sub 1 of the form a multiplied by e raised to x multiplied by 1 plus the square root of 5 divided by 2, and we have a second solution f sub 2 is equal to b multiplied by e raised to x multiplied by 1 minus the square root of 5 divided by 2, where a and b are just constants, which we would determine using initial conditions. But we don't have to worry about that because we've not been given any initial conditions. Now, we can use the principle of superposition to get a more general solution. The principle of superposition allows us to combine our two solutions, f sub 1 and f sub 2, to get the following final answer to our problem. Now, as a final exercise, why don't you make sure that f of x satisfies our differential equation? Anyway, that's the final answer to our problem. Thank you very much for watching. I hope you found this content useful. If you have any questions or problems you'd like to see solved in future videos, let me know in the comment section below. I hope you have a great day.